We will focus on the parent material, the drainage, and native vegetation in the station. So the first soil that we have is the POA series. The POA series give us a hint. It says we have a low bulk density here in in aluminum silicate minerals. So these are the two characteristics that we will find in the volcanic material. So the parent material for this soil will be volcanic. Since we don't have the gray colors, it's a bright color throughout. So it will be a well-drained soil. And in terms of native vegetation, we have more than 10 inches of dark material, somewhere like up to 13 inches. So that's why we will call this as a prairie soil. And then the next soil is the Hafton soil series. And then this soil series will be found in the marsh, in the swamp area. And it's black materials all the way through. So the native vegetation will be marsh, and then the parent material will be also marsh. And then in terms of drainage, we know that these are in the swampy area or marsh and bogs, so these will be poorly drained. The Montgomery soil series is another poorly drained soil that we have gray colors all the way through. And then in terms of native vegetation, we have forest, because that is not more than 10 inches of dark materials on the surface. And in terms of parent material, we have less materials, or the silty texture material, that is wind-blown silt. So it will give us a silt loam if we texture on the surface. And then in the bottom, we have glacial till materials, which is mixed in the dense compacted material. We have some other good example of glacial till, which I will show you in a few minutes. And then we have the next series is the Byington one. And the Byington in the bottom has these shells. So shell is the residuum parent material. So we will have shell in the bottom. And then we have at the surface again silt loam, so it will be less over shale. And then in terms of drainage, we have the gray colors will be up to kind of close to like below 18 and above 30. So this will be a moderate well drain. So we have gray colors somewhere stopping here. So this is an area that is above 30 and below 18. So moderate well drain forest soil, and we talk about the parent material. So the Novogorod series, Novogorod series soil series will have these gray colors. These gray colors are not from the water table. These are coming from a root channel, and you can trace these one to the top surface. So those root channel bring water from the surface and cause these reduction in here. So in terms of drainage, we will have a bright color soil and a well-drained soil here. And then in terms of native vegetation, so we have another forest soil, not deep dark material. And in terms of parent material, we have these layers. We have layer material, and these are deposited by stagnant water or gentle water. So this will be like an indicator of lacustrine. In the lake environment, we will have this sediment. And then at the top surface, we might have again silty material or less. Then we have the Forsman soil series. The Forsman soil series has nice deep dark material, so another prairie, no gray colors, so bright color all the way through. That will be a well-drained soil. And someone might ask, what are these? Then these are not gray colors first, and if they are, these are not coming from the water table. These are coming basically from the top surface, and these are dark material that are taken up by root channel or an earthworm channel from the surface. So we are ignoring those ones when it comes to judging about the drainage. So we have well-drained soil, prairie, and in terms of the parent material, we have a good way to indicate this is a glacial till. We have a rock here, and we have another here, and then we have maybe another somewhere here and here. So those are just like mixed material throughout the profile in dense compacted. So Tree Haven is the next soil series. Wind-blown sand material, all sandy. We will call this eolian sand or dune sand. And forest, native vegetation. And then in terms of drainage, bright color, so no drainage issue. Coal Creek, we have these dark, bright, dark, another dark and bright color soil sequence or varves. And these will be found in the floodplain area. So the parent material for this one will be alluvium. And then in terms of vegetation, we didn't have that indicator, but we can say this is a forest soil. And in terms of drainage, we know these will be found in the floodplain environment. From that knowledge, we can say these will be also poorly drained soil. And then we have the Weikart soil series. This series will be made, the soil is exactly coming from the parent material underneath. So this is the residuum parent material. and these are the soils that are made from this residuum. So it means they are not transported by any factor like wind or water or glacier, so just directly made from these materials. In terms of vegetation, we have forest, and in terms of drainage, no gray color, so bright color, so well-drained soil. Chalmers is the next one. So you see gray color and brown color mixed together, so like we have models, and then gray color is going all the way to the surface, so this is another poorly drained soil. Nice deep and dark, so that will be another indicator of a prairie soil. And then again mixed material, kind of dense compacted, so that will be an indicator of glacial till. Kalamazoo is the next one, and this is a good comparison to compare the glacial tills. All of these are glacial tills as well, which I will talk about them. And then we have the glacial outwash. So glacial outwash materials are sorted. We have stratas here, which will be hard to see this strata in sorted materials here in a small monolith, but we need an open space for that one. But you can tell that we have stratas here of the finer materials, slightly coarser, and then more coarser in the bottom here, and then again finer materials at the very bottom. So that will be the sorted strata, coarse gravelly material. These are all indicator of a glacial outwash versus glacial till. So bright color, well-drained forest. The Miami complex is another glacial till, forest, and then the drainage will stop somewhere kind of above that 13 inches mark, and then in below 18. So somewhere in this region we will have that moderate well-drained soil. Daniels is another glacial till. We have mixed materials again, and then we have the gray colors are extended to the surface, but the main matrix color above that 18 inches zone will be mainly brown or brighter color. So therefore we will call this as somewhat poor in a state of a poorly drained soil. This is another indicator or soil that has prairie vegetation because of the deep dark surface. And then in terms of native vegetation, we talk about prairie, and then in terms of like drainage in prairie material, we say that this is somewhat poor in glacial till. So that is the Daniel series. The Seidel, Salina, and Toronto, those are all glacial tills. And then at the surface, they might have some loess as well. Some of them, like maybe this one has loess, and this one might have loess material. But the main one I'm interested is the glacial till here in the bottom one. And then all of these three, Seidel, Salina, and Toronto, will have forest native vegetation. So Seidel is another bright color soil, so we have another well-drained soil. And then Salina is another one that has gray colors that is stopping somewhere in this region, which is above 30 and below 18. So another moderate well-drained soil. And then we have the Toronto, again, the same thing. We have another candidate of moderate well-drained soil. So, and we talk about the native vegetation of them, and then we talk about their parent materials. Toronto has a nice boundary of an AP horizon, a very sharp change of the boundary. So that will be an AP horizon here. So this is it about the parent material and native vegetation, and then the drainage, that how you determine the drainage and native vegetation in parent material in a soil monolith here.